Okay, time to get started. My name is Di Clegg, and I'm Director of Product Marketing at NuoDB. And I'm joined by Knox Anderson, who'll be driving the tour demo for you today, and Adam Abravea, our VP of Engineering. So the highlight of today's webinar is going to be a walkthrough of hands-on NuoDB tour. It's available for download, so you can take the tour yourself, but just to save you a little time, or maybe to encourage you to take that extra time to do it for yourself, Knox here is going to do the tour for you. But before he does that, I'm going to take a few minutes to set a wider context for the tour, tell you a bit about what NuoDB is, what it does, and why it's different from a traditional relational database. And we will leave time after the tour for Q&A. And please do post your questions as we go through in the chat pane, and we'll pick them up at the end. We plan to be done in about 30 minutes, give or take. So I won't waste any more time. We'll get right on with the show. So first and foremost, NuoDB is a SQL database with all that implies. It has the rich programming environment, familiar tools, well-supported APIs. SQL databases, they've been around for decades, successfully delivering mission-critical systems. And of the $40 billion a year database market, according to IDC, almost all of it, 90% plus, is SQL databases. And that surprised me when I found that out. You'd think it was the reverse, given all the hype and the media attention on the alternatives. But the fact is, SQL is still running the shop. And that's good, because it means we have the skills, the tools, and the experience to exploit that. Where it's not so good is where SQL databases don't adequately meet the needs of what is now a whole new paradigm, cloud-based solutions for a mobile, widely distributed user base who they expect their applications to be always on and local everywhere effectively. And that's a different world. But as well as the SQL language itself, the other critical dimension of a SQL database is transactional consistency. I'm not going to go through the computer science of ACID transactions, atomicity, consistency, isolation, and durability, but I will take a moment to emphasize just how important it is that when you make an update, you want to make sure it isn't lost or overwritten. When your users query their wallet of minutes or credits or whatever on one device, they expect that it will reflect the change they just made on another device. And you, as a developer, you don't expect to have to design and code this into every application, and you don't want to have to think about the implications of multiple users accessing the same data at the same time through different bits of the application. Now, you're smart people. You can work these things out. You can write the code and the tests to get that right. But that's all time and effort spent away from adding value to your organization. It's just more plumbing code. And SQL database users expect their database to take care of that. We'll see just how easy it is to scale out NuoDB in the tour demo. And we can pick that up in the Q&A if anyone has further questions. So I won't spend too much time talking about that now, beyond pointing out just how vital scale-out is in virtual and cloud environments. Traditional databases scale by scaling up onto bigger monolithic machines, and that gets very expensive as you get into high-performance computing realms. And it's in sharp contrast to the economic model of cloud computing, which is scale out or a bunch of commodity boxes. Scale up just doesn't work that well with virtual computing. And another thing that Knox will show you in the tour is NuoDB's resilience to failure. The architecture is all about peer processes running on a collection of hosts, potentially in multiple locations, so there's no single point of failure. You configure more processes for redundancy, to increase resilience, for improved throughput, for increasing workloads. But either way, it's transparent to the applications. They just keep running. You can choose a minimal configuration, which is what Knox is going to start with, maybe so you can develop on your laptop. But when you deploy to production, you're going to use a more robust configuration. But you make no changes to the application to achieve that. There's no need to consider the final consideration when you're writing the code. The application, all these changes in configuration are completely transparent to the application code. Now, what we're not going to show you today is NuoDB's geo-distributed capability. So you can run it maybe in different data centers or cloud regions, but we'll be showing it on a single laptop. If you were running the tour on hosts in 3 different geographies, the behavior would be exactly the same, give or take a few tens of milliseconds of latency. And the application client code would be identical. Scaling out to multiple hosts in one location or in many is completely transparent. And this is a critical requirement for many of our customers. The main reason they come to us in some cases is because it's just so complex to manage geo-distribution of traditional SQL databases, even if you're only doing it for disaster recovery. And achieving active client connections updating from multiple locations has really only been achievable by leaving SQL databases behind and going to NoSQL. You lose the rich and mature data management environment that the SQL delivers, and that's bad enough. But if you go to NoSQL, that also means going to no transactions, and that's a no-no for lots and lots of use cases. But we're planning another webinar to demonstrate multi-cloud region NuoDB, and you'll get an invite for that. Meanwhile, back to today's objectives. So to make the initial tour of the product as simple as possible, we've set it up to run first in 1 Docker container and then in 3 to demonstrate the scale out and the resilience. And the start point is the download from www.nuodb.com. And then we'll fire up 3 Docker containers we're going to need. Then we will define a NuoDB domain across those 3 containers. A domain is just a collection of hosts, real or virtual, that NuoDB knows about and can use. Then we'll install a start database in that domain, initially on just 1 of the 3 hosts. A NuoDB database, incidentally, is made up of transaction engines and storage managers. The TEs, transaction engines, accept client connections and they manage their transactions, querying, updating, committing, and the storage managers manage the persistence of the data. We'll do a bit of SQL testing on that single host configuration, and then we'll reconfigure it with a single command, no interruption of the database services, and deploy the database across all 3 of those hosts with redundancy for resilience. Then we'll start some clients up to load that database, and then kill a process while the query load is running and see how it recovers. That's going to take us probably about 10 minutes to do all of this, which is the 10 minutes you really wanted to see. So I'm going to shut up and get out of the way.
Thanks, Di. Let's get started with the NuoDB tour demo. The tour is designed to showcase the scale-out, resilience to failure, and administrative capabilities of NuoDB. Built on Docker container technology, the tour demonstrates how easy it is to install a NuoDB database, load data, and leverage distributed processing capabilities across multiple containers with the ability to withstand failure. We're currently running on an Ubuntu VM with Docker installed on a MacBook. To start off the tour, let's navigate to the NuoDB TGT directory that we had downloaded. First, we'll run the setup.sh script. This is setting up our environment and downloading NuoDB so it can be installed on the containers that we will run during the next step. Now that the download has completed, let's run the deploy.sh script. To do this, we'll need to enter the credentials that we'll want to use to manage the NuoDB domain going forward. As you can see, the script is now starting 3 different containers, NuoDB1, NuoDB2, and NuoDB3. Each container has the NuoDB software installed and is part of the NuoDB domain. A NuoDB domain is a secure environment for deploying and managing NuoDB distributed databases. A domain can contain 1 or more databases, and each database can run on 1 or more hosts. Now that we've deployed our containers, let's take a deeper look at our environment. We can now see that we have 3 Docker instances, which are our 3 separate NuoDB hosts, a Java API, which is the REST service for NuoDB domain administrative tasks, and 3 Java NuoAgent jar processes, which are the NuoDB brokers, 1 running on each of the 3 NuoDB hosts. What we'll do next is start using the NuoDB manager to interact with our database. The NuoDB Manager is a command line tool that lets you monitor, analyze, and control a NuoDB domain. What we'll do first is a domain summary. The domain summary gives us a high-level view of what's going on in our domain. As you can see by the output, this confirms that we have 3 separate hosts which are represented by the Docker containers we installed earlier. Now that we've seen our domain, let's actually do something interesting by creating a database. I'll use the NuoDB Manager tool to specify my database name, username, and password. From there, we have multiple template options. For this case, we'll choose a single host template. Finishing up, we can set other database parameters such as memory allocation and what host we'd like to start the database on. Now that we've created our database, let's see the domain summary again. Now our domain summary shows 2 additional processes running, 1 transaction engine and 1 storage manager, giving us an active single host database. In just a couple simple keystrokes, we've gotten a new database up and running and ready for action. Now that we have this database running, let's execute some simple SQL commands to create a table, insert some data, and query it. For this next section, I'll take some SQL statements that are in the NuoDB Tour instructions and copy them in. The first will create a table users, while the second will enter data into the table. We can run a quick select star statement from the users table to see all the data that we just entered. If we'd want to drill down further, we can run a show table to see the fields and their data types. So what we've seen so far is pretty standard for a SQL database, but it's worth getting the basics of a relational database out of the way before we show you the cool abilities that come with being a distributed system. Now that we've played around with some basic SQL and a single host database, let's make things more interesting by updating our demo database. Let's say I'm not happy with the lack of resilience in my database and I want to configure some redundancy. How do I do that? We'll need to log back into the NuoDB Manager to connect with our domain. Changing the processes that we have running is as simple as updating this template from single host to minimally redundant. With this change to the minimally redundant template, several important capabilities of NuoDB come into play. First, there are now 2 TEs and 2 SMs in operation, which means that if any process goes down, the database remains up and running. Also, there are now 2 copies of the data on disk, which provides data redundancy. Finally, with extra TEs and SMs in operation on additional hosts, the overall performance of the database would increase. This is called horizontal scale-out. And best of all, we accomplish this with no interruption in service. Now that we've scaled out our database, let's make things more interesting by importing some more data. We can copy some SQL files that are part of the NuoDB Tour package and run them to insert some sample hockey data sets into our database. Now that we've inserted our data, let's take a look at what's in there. First, the hockey schema that we just created. In there, we can see our hockey, players, scoring, and team tables. Now let's drill down further into the players table. As you can see, this table contains all the information that would normally be listed for roster information, such as position, height, and weight. We'll do a quick query to show that these tables will behave just as we would expect, even though we have an extra TE and SM running. As you can see, the results are what we would expect from a query with a limit of 10. Now that we've imported some data into our database, let's drive some load to make this more interesting. We'll start some sample JDBC clients that will continually query the tables in the hockey schema. To start these clients, we'll simply run the 3 clients that were shipped with the NuoDB TGT package. Now that we've got these 3 clients running, let's see how they're interacting with the database. We'll do this by going back to the NuoSQL tool and querying the SQL string and node ID from our systems.connections table. This will output the SQL string and what node each JDBC connection is accessing. The interesting thing to pay attention to here is the changing SQL strings and node IDs. Node IDs 2 and 4 are the TEs, and we can see that our transactions are being evenly distributed across both TEs. And you can also see my query of SQL string. It's just another connection to be managed. This required no application tuning or database tuning besides making the update to the database template. If your database ever becomes bottlenecked, simply scaling out to more TEs can bring you the transaction numbers you're looking for, pretty much instantaneously and with no disruption to the workload. Let's take a look back at our domain summary before we go forward with our next step which will be unexpectedly killing a TE that is running. What we'll want to pay attention to here is the node ID. To shut down a process, I'll have to enter the host tag and specific process ID that I want to kill. Let's now check the domain summary to see what's happened. As you can see, there's no longer a node ID 2 and a node ID 5 has been added to the domain. This is because the demo database has a service level agreement enforced by the minimally redundant template. If any process goes down, the NuoDB will automatically start and sync a new process to meet the redundant setup of 2 TEs and 2 SMs. If I had ran the domain summary quicker, I might have caught the database before the new TE was started, but I would have had to be fast. Let's go back and use the NuoSQL tool to check that the new TE, node ID 5, is processing transactions like it should be. As you can see by the output of the query, node ID 5 is processing transactions as expected. Not only can a NuoDB database be updated without downtime, but it can adapt to failure as well, once again without any changes to your application. That's the end of the demo. We've seen install, setup, initial testing in one virtual host, scale out to multiple hosts, and resilience to failure, all in less than 10 minutes. And now I'm cleaning up my installation, just to reassure you that if, and I hope you will, try the tour for yourself, it's not going to leave anything lying around when you're done. That's the tour finished. I hope it's been interesting. Let's go back to Di and take some questions.
Thanks, Knox. That's great. And it was pretty quick. So let me just take a second to recap what we actually looked at there. So we took Knox's laptop and created 3 Docker containers on that. We defined a NuoDB domain across those 3 containers, and we started up a database in just one of those, a single host configuration. Knox did some testing on that. Then he decided he wanted to add the resilience. So he switched the database configuration, basically just redefined what the service level agreement was for the database to minimally redundant. That required it to start up a second TE and SN. Then he cracked on with a little bit of testing on that, and then got a little bit sneaky and killed TE2. But by the time that he'd run the admin query to spot that, it actually started up a new TE and was rebalancing the load across that. So that's not bad for about, I think, 9 minutes, Knox, for installing, configuring, starting, testing, scaling out, testing resilience, killing a process, watching it recover, and all with no interruption of service. So that's the lightning tour. I'm going to pull Adam in and bring Knox back, and we'll take some questions. Okay, so first question for you, Knox, is can I run the tour on my Windows box?
So the first answer there is for the TTT specifically, you need to use some type of Linux instance, but you can run that. If you have a Windows machine, you can fire up an Amazon instance really quickly, or get a VM and run it from there. But for our general software, you can run it on Mac, Windows, or your favorite flavor of Linux.
Okay, that's great. Thanks, Knox. There's another question here, which is how long does it take for a new process to become active? I'll take that one because I did talk about that briefly. Basically, a new transaction engine starts to accept the connections pretty much immediately, milliseconds. As we saw, Knox actually couldn't catch that TE engine missing. It already restarted and was taking connections by the time he ran the admin command. But a new storage engine, if you bring a new storage manager online, it needs to create itself an archive of whatever data it's responsible for. And so it will sync with the other storage managers first, and that can take a little time.
So I have a question here that it's probably good for Adam to answer, and it's how rich is the SQL syntax if you compare with something like Oracle?
Okay, so we support SQL 92 standard We support a lot of the SQL 99 extensions, and we've also built a number of other extensions into the SQL we support, just to make it easy for customers to migrate their applications over to NuoDB. And generally, anyone who's used a ORM mapping tool like Hibernate or something like ASP.NET and Link, it's very easy to move over an application from another database to NuoDB. So we've got a very rich SQL syntax, and it's very standard.
Thanks, Adam. Got another question here, and I think I'll take this one because it's a nice, simple one for me. Can I use the tool for a general purpose evaluation of NuoDB? And the answer to that is, well, the tour actually uses our community edition. And if you want to do a full evaluation, you're probably best off using the enterprise edition. That one has a price tag, but if you go to the editions page linked in the menu of nuodb.com, you can request a free evaluation license there.
Another question just came in. It's, does it support partitions, etc.?
Yes, so the current version of the product 2.3 has a preview version of table partitions and storage groups. So anyone who downloads the community edition or an evaluation of the enterprise edition will have access to that. That feature's going to be available in GA, we expect before the end of the year. But it's a full partitions feature, and it's got some interesting capabilities for how we map storage groups to different storage managers. So we're able to do I/O scale out very, very well with our system.
Another good question for Adam is there a GUI that allows you to administer the database?
Yeah, we ship a GUI called the Auto Console. It allows you to start, stop databases, to monitor them. It's a rich but simple GUI. We also support a REST API, command line API, to make it easy to automate things and to integrate our administration capabilities into other tools if necessary.
Another question that we had come in, do I still need to use Hibernate for caching, or can I go straight to NuoDB to get performance?
I get asked that question quite a lot, and generally I say don't turn on caching. If you have TEs running close to or on the same machine as your application, you get in-memory performance. You get less benefit from caching and Hibernate.
Another question was, how easy is it to migrate from another SQL database to NuoDB? We've got a number of customers who actually, one of the prime reasons they came to us was because of the ease of migration. And the product does include a migration utility with specific coverage for most of the major platforms. And if you I can't remember the link to the doc page off the top of my head, but anybody wants that, then we'll make sure to publish that in the Q&A follow-up after the webinar.
And for the last question of the webinar today, we got a pretty interesting question that's related to one of our new features, and are backups just exports and any point in time capabilities?
Yes, so in the currently shipping release 2.3, we have a feature called Hot Copy, which allows you to do an online backup of the database. You don't have to take anything down. It takes a transactionally consistent backup of the database. We also have a snapshot storage manager that's part of the 2.3 version of the product. It's in preview right now, but the idea there is the system will take snapshots at an interval that the user specifies, and you can go back in time to one of those snapshots and get a transactionally consistent copy of the database. All right. Well, everyone, thank you for logging in and joining with the Q&A. If you look on the screen right now, you can see a link to the NuoDB Tour, which is the demo that you saw today. And we suggest all of you to try it out for yourself. It's an interesting experience, and I think a lot can be learned from it.
I hope so. Thanks very much, everyone. Thanks, Knox. Thanks, Adam.